So Java supplies several types of collection. So the set cannot contain duplicate elements, and the order is very important. A set cannot contain duplicate elements, and the order is very important. You have different variations of the set. You have sorted set. It's like the set, but the order is, for the set, the order is not important. The order is not important. You just need a set of this. But you have sorted set, which considers the order very important. Apart from the sorted set, all the rest, the order doesn't matter. And the unique feature of our set is that it cannot contain duplicate elements. Each element should be what? Unique. That's why the order is not important. Because there's no duplicate, you don't care which one comes first. We all know that you are in a set. But you have a list. A list may contain duplicate elements. Because it contains duplicate elements, we need to keep track of the what? The order. So that you can track each one's index. So even if there's duplicate, we don't care. You are tracking by what? Index. But when it comes to set, the order is not important, but it cannot contain duplicate elements. Then the third type is a map. A map is a dictionary. The order is not important. When you say it's a dictionary, when you are looking for a meaning of a word, you go with the word by searching through the index. So when you found the word, you see the definition of that word. So every word in the dictionary has a key and a corresponding value, or the meaning. So the word meaning. But here we say key value pair. The keys are unique. The key cannot be duplicated. In maps, the keys cannot be duplicated, but the values can be as duplicated as much. Each value is identified by the key, so the keys are unique. Then you can see here too, anywhere you see sorted, the order is very important. So for the sorted set, the order is important. For the sorted map, the order is also important. Look at the last bit. Whilst you can get all the details from the Java API, you are expected to memorize the method signatures of the most important methods in each interface, and the most important implementation of each interface. That one you must know them. It's part of the syllabus. So you must memorize them and use them. We will discuss everything, don't worry. So this is how the hierarchy looks like. So you have the collection interface, then under it, you have the set interface, list interface, then you keep coming down. You have so many different variations. Anytime there's a new Java release, there's an update to this of any of this collection. And note, even though the map, we treat it under the collection framework, it doesn't come from the what? The collection hierarchy. The map is on its own. The map is on its own. It doesn't depend on the collection. It's only the list and the set which depends on the collection framework, the collection interface. So this is how the diagram looks like. Here, all these are interfaces. So from here, they are interfaces. So this is an interface, and these are subclasses of this interface. You can extend the interface. So this one will extend this. This set will extend this. This one will also extend this, and this one will extend this. You have queue. Then after the set, you keep coming down. You have SORTEDSET, which is also an interface. Then after the sorted set, we come straight to what? Anytime there's sorted something, the order is very what? Important. And you know that this tree set is coming from what? Sorted set. So meaning when it comes to tree set, the order is very what? Important. The order is very important. Then straight you have an abstract. Before you come to the abstract classes, the list also comes from the collection framework. Then you have a queue. You have the queue. The queue here is double-ended queue. Double-ended queue. When it comes to the queue, just as the word is there, when it's being treated as a data as a data structure, it is called double-ended queue. But when it's treated as an operation, it means you are removing something from the what? The queue. When it comes to queue, it's either you are in queue or the queue. When it comes to stack, you push and pop. When it's an operation, when the queue is an operation, it means you are removing something from the what? The queue. But when it's treated as a data structure, it means double-ended queue. A queue with two ends. Then the abstract classes, we have abstract set, abstract collection, abstract list, abstract stuff, before we come to the concrete classes. So now that you know what an abstract class can do, and if you think any of these concrete classes, whatever they are doing, you don't like it, you can extend from the abstract class yourself and do what? Create your own version of what? Collection class. Abstract class cannot be what? Instantiated, but they can be what? Inherited or extended. So you can extend from any of these abstract class and customize your own collection class. Now, so these are the class that we'll be learning: tree set, hash set, vector, array list, linked list. You know, focus much on the queues and the stack. There's also a stack class. So these are the concrete classes. You should know the hierarchy and from where you are coming and where you are going. When it comes to collection framework, you have three main things under the collection framework: the list, the set, and the map. But there's a collection interface, this collection. And the collection interface, you have only two subclasses. It's more than two, but the main two ones are the list and the set. They are under this interface. The map is also a different interface. It's not under here. But when it comes to the framework, you talk about three main things: list, set, and what? Maps. The list and the set are under the collection interface. You have the framework and you have the interface. Queue is also part. You have other ones to stack. Now let's look at the map interface. For the map tool, you have the map as an interface. Anytime you see this angular braces, it means you are talking about generics. And this one is key value. The key cannot be duplicated. The key should be unique in each map, but the value can be any. It can be duplicated. It doesn't matter. We don't care about that. Then when you come here, you have an abstract map. And also you have another interface, sorted map. Anytime you see sorted, it means the order is what? Very important. So when it comes to the sorted, we have the first key, last key, comparator, head map, tail map. But when it comes to our abstract class here, see here you have what? Hash map. Then you have what? Tree map. Tree map also implements this interface. This is a concrete class that extends from this abstract class and implements this interface. So it has both methods in this class and this class. Whilst we have the hash map, it only comes from what? The abstract map. So it doesn't have these methods, the first key, last key, and the benefit that comes from what? The sorted map. So that's the difference between the hash map and the tree map. They are both maps. But one, the other is very important. One, the other is not important. The tree map, because it implements this interface, the other is very what? Important. But here, it just extends from this abstract class. Then you have a specialized version, linked hash map. It also comes with its added methods. Again, also with the set interface, you have all these set methods. And just like the hash map, the map interface, you have the set interface, abstract set, hash set, and the tree set. The tree set also what? Implement the sorted set, another variation, navigable set. Anytime there's a variation of the interface, they add extra methods to it. You can navigate first pole, last pole, lower, higher, floor, and ceiling. So you have the hash set and the tree. So anytime you see hash, it's coming directly from only the abstract class. Anytime you see tree, It's coming from the abstract class plus what? The sorted what? Version. There's always a sorted version. Collections are ADTs, abstract data types. So let's start with the actual collection interface. You said the important methods. You are starting with the methods. So from the collection interface, there are many other operators or methods, but these ones you should know them, and that's what you'll be playing around with. So you have the Boolean add. This add E means what? Enumerable. We'll talk about it later. Then it contains an object. You can remove an object. It's empty. The size. Then you can convert to an array. Convert to an array. You can convert a collection to an array. Then there's an iterator that is used to look through the content of each collection. So you should know about the add method, the remove is empty, and the iterator. The iterator is used to what? Iterate through the what? The content of each collection, instead of using a for loop. There are times you want to do some bulk operation. You want to check whether a collection contains another set of collection. Maybe you already have a set of something. You are coming with another set. So you check whether it contains this set to return true or false. Collection.singleton. I says anytime you have singleton, it means there's only one what? Copy. If you want to make a class singleton, you make the constructor what? Private. You provide a static method that will what? Return only one instance of what? That class. And that class behave like what? Singleton. There's also a singleton method that will return a mutable set containing only the element E. So you just create a singleton version for you. Just as you have then the iterator interface is very important for you to understand the iterator interface. It will return the elements of the collection one at a time. So it will return the elements of the collection one at a time. Now, it has this method, hasNext. The hasNext returns true if the iterator has more elements. So it checks if the iterator has more elements, it will return what? True. So hasNext returns what? True. Then the next method returns the next element. You remember the scanner class. When you create a scanner, scan is equal to new scan system.in, and you want to get something, say next int, next this, next this. It gets the next element. So anytime you see the next, it returns the next element in the what? The iteration. Then you have the remove. It removes the underlying collection that the last element returned by the iterator. It removes the underlying collection that underlying collection's last element returned by the iterator. The next returns the what? The next element. It will return you the next element and to loop through again. So if you have 1, 2, 3, the next we check while this collection has next. If there is data to check, there is data inside. Then next means return me the first element. Then remove the what? The last element returned by the collection. Are you confused? You have 3 rows. The next will return as the first row. And the remove will also remove the first row. See it as such. Because if you have to return anything, return what's in the first row. So whatever the next returns, the remove also what? Remove it. So the set interface. So now if you move from collection methods, you are moving down. So you're in the set interface. Now, you know in inheritance, when you inherit, you can override a method and give it other meanings. So this set interface also has these methods. Don't forget, there are no duplicate elements, and the order is not important when it comes to set. There are no duplicate elements, and the order is not very important. Set interface implements collection and iTravel. So you have the contains method, membership test, contains or subset test. Are you getting it? The contains or subset. This is a subset of this row or this collection. So subset test. Add or union. Set. They are treated like this, like a math set. Add or union. You are putting everything together. Retain or intersection. Retain or intersection. So you have this set and this set. When you say retain or, if there's an intersection, that one will be retained. So this one set, this one set. When I say retain or, these two guys will be retained. Then you have the remove or the difference between the two collections. And the color. So this is the set interface. As we were discussing, contains membership test, whether you are part of it, contains or subset, add or union, retain or intersection, and remove or difference. Then going on with more of the methods. When it comes to list, remember when we're in the here in the collection interface, the add took only one parameter, or the add takes only one parameter. But when you come here, the add takes what? Two parameter. When you are in the list, the index and the actual element that you want to add there. So for the add for this list takes the index and the actual element. So if you want to insert or add at a particular index, you pass the index, and here the actual element will be here. If you want to remove, you need to pass the index. Remove. If you want to remove, given the index, it will return you the item. Then remove the object. This one will return you true or false, and this remove is coming from the superclass. This remove, the same remove. This one returns boolean. So when it comes in, you have two removes. Either the one that returns you the element when you give it the index, or the one will take the object directly and return true or false, whether it was successful in deletion. Then you have the set. You set an element at an index, then you get an element at an index. Then also you can find the index of a particular element so that you can play with the index. So using the index of method. So what is the index of this item? Then the last index of the last most important thing is that when it comes to the list, we know that the collection interface has an iterator, and the iterator is used to what? Iterate through all the objects using the has next, and remove. The has next checks whether if there are data in the collection. Next returns as the data in the collection, each data, like one letter at a time. Then the remove removes it for us. When you come here into the list, you have list iterator. It's a modified version of the iterator interface, or the iterator interface. So the list iterator is the iterator, but it also has some additional methods. Has previous and previous methods. Then it comes to the sorted set. Anytime you see sorted, the order is very what? Important. So this one implements set, collection, iTravel. This iTravel interface contains the that iterator. So it has two sets of methods, the first and the last. So only comparable elements can be added to the sorted list, sorted set. Now, when you say comparable elements or classes that implement the comparable or the comparator. You have the comparator interface. So if your class implements the comparator, then that class is what? Comparable. So you can add only comparable what? Elements to what? Sorted set. Because the order is very important. And once you implement that comparator interface, you have to override either a compare to a comparable method, which will help us to achieve the order feature. Then you come to the map interface. You said the map is what? Key value pair. The keys are unique for each what? Element or each value. So this is the interface. The two most important methods are, when it comes to map, you don't add, you put and you get. But when you go to the other one, you add and remove. Map, you put and you get. So these are the two. So when you are putting, you put with the key and the value alongside. But when you are getting, you go with the key and you get a what? The object. And the key can be anything, but it should be of type object. Then there are some other methods that we'll be using in the map. You have the key set, which returns as a set view of the what? Keys contained in the map. Then the values. It returns a view of the collection contained in the map. Map contains keys and values. So the key set returns as all the keys, while the values return as what? All the values. Then you can look through one by one and get your actual values according to the keys. The sorted maps too, because it's sorted, the order is very important. First key, last key, it works on only comparable elements, and the class must implement comparable interface. So some of the implementations. Before you see this from the diagram, the hash set implement the what? The set. The tree set implement the what? The sorted set. The array list implements list. Linked list implements list. And vector implement list. So 1, 2, 3, they all what? Implement list. We'll discuss the difference between all of them. And a stack class, it extends from what? Vector. You know how stacks work. You push and you pop. First in, last out. Stack is first in, last out. Stack. Golf hole. The first ball will be the last. Last in, first out. It's the same as philo. First in, last out. First in, last out. Only one entry. So don't just say lifo. You see first in, last out. You say no, that's wrong. That's correct. So you have the stack, and you see that the stack is coming from what? The vector class. You also have the hash map, which implements what? The map. Anytime you see hash, it tells you that what? That collection doesn't care about what? Order. Because anything hash does not implement the what? The sorted set or the sorted something. So anytime you see hash, order is not important. But when you see tree, the order is important. All the hash are not coming from the sorted set. So you have the hash map and the tree map. A set does not support duplication. A set cannot contain duplication. That's why in the list we don't have sorted list. The sorted is only for the two, the map and the set. It's only for these two, the map and the This is the diagram. Everything is based on this. We are coming back to this diagram. So all the above provide no arg constructor. That's the default what? Constructor or parameterless constructor. There's no parameter or no arg parameter. So if we already seen this methods, add or get a particular index, last index of list iterator, set interface, so we've seen this. Before seeing this, it's just a duplication of what we saw earlier. The collection, the list, the set, the abstract collections, then it keeps coming down. So the array list, and a stack is a product of what? A vector. A stack extends what? The vector. Whilst the queue comes from the top here. So let's look at the differences between vectors, arrays, and linked lists, and when to use which one, and why to use it. Now, vectors try to optimize storage requirements by growing and shrinking as required. Vectors are just like dynamic arrays. You know, when you create an array, you must specify the size. For the vector, when you are creating it, you have what you call capacity. So when you want to store 5 items, I say create a vector for 5 elements. That's the capacity. After specifying the capacity, when the collection grows or there's an increment during runtime, the vector will automatically what? Double the capacity. So if your capacity was 5, it will increase it to what? 10. So when it's filled up, it will increase it to what? 15, 30. So assuming you start with a capacity of 20, when you're able to use up to 19, the vector is effective. But when you get to 21, it will double the capacity twice. So the vector will be allocated with what? 40 spaces. Meanwhile, you are using only what? 21. So sometimes the vector is ineffective because of these features, because of the capacity feature, which doubles anytime the vector is full. And methods in the vector are synchronized for multi-threading. We'll talk about it, so for now just ignore it. Array list required. When you remove it, it reduces. For all the collection, you have add and remove. So when you keep adding element, the capacity will increase, or the content will increase, or the size of that collection will increase. When you remove it, it will shrink. So all the collections increase and shrink at runtime. And this is, you don't have to specify the size during compilation time. It's only the vector that you must specify the capacity. If you don't specify, you get a default one. Now, the vector came before the array list. And vector, as at that time, was synchronized. The array list was brought in. It works exactly like the vector, but that one you don't have to specify the capacity. It's pay as you go. If you add it, you get a size. If you remove it, you lose it. And it's internally implemented as a linked list, double linked list also. But just know that the methods are not synchronized. We talk about synchronization. Then linked list implement double linked list of the element. That one also came with the array list. So as at that time, the methods were not synchronized. So I'll come back to this three. Let's proceed. Now when it comes to the set, so this is the list. For the set, hash set behaves like the hash map, except that elements cannot be duplicated. Set contains what? Unique elements. That's why you don't care about the order. The order only becomes important when it becomes what? A sorted set. Tree set behaves like the tree map, except that The element cannot be what? Duplicate. Anything set. What is so unique about set? There's no what? Duplication. What is so unique about list? The order is very important. List is already ordered. List, the order is important. That's why we don't care about duplicate. And we use indexing. Talk about the common methods. So now, which class should I use and when? So you can see that all the collection classes provide similar functionalities. And the difference between the classes is how the structure is implemented. Now, use vector when you want fast access to elements using index. And for optimized storage space. But it's not optimized for what? Insert and delete. It's not optimized for insert and delete. But if one wants to access, that one is faster. And when you want to insert, no. Then for the array list, they use just like the vector, except that they are not synchronized and they have better performance over the what? Vector. So don't use vector. Always try and use what? Array list when you want something of type arrays. Then for the linked list, you know how the linked list works. First insertion and what? Deletion. When you are inserting a linked list, you just go to that node. You take the pointer, point to the incoming node. Then you send your node to the what? The one which the other one was already pointing. So you just insert. It's the same with the deletion. You just cut this one out, you delete it. You just manipulate the pointers and you are done. So it's faster. Stacks and queues. You know you can implement stacks and queues using what? Linked list. But the linked list is not optimized for random access. Then use set when you need a collection which does not allow what? Duplicate entry. Use map for fast access of elements using keys. So maps are just like what? Dictionary, key value pair. So if you know the key, for faster addition and removal, no duplicate keys are allowed. So when choosing a particular class, it's good to read around it before you make your choice. And know whether this one suits what you want to do. You don't just choose one and keep going. So you notice that some classes provide ability to sort elements. Java provides two ways of comparing objects. An object that implements the comparable interface, and a comparator object is used to compare the two objects. So if the objects in question are comparable, meaning they implement a comparable interface, then we say that these objects are sorted by their natural order. If you have a class that implements a comparable interface, then we say that objects of that class are to be sorted by what? Or are said to be sorted by what? Natural order. If it's alphabet, A, B, C, D. If it's 1, 2, 3, in order of what? Increment or decrement, or ascending or descending. Comparable objects can only refer one form of sorting. To provide multiple forms of sorting, comparators must be used. So you have the comparable interface and you have comparators. One may ask, why can't you use the what? The equals method. Remember, these two guys, the comparable and the comparators, we are only talking about the sorted types. And the sorted types are found under either the sorted set or the what? The sorted maps. Anytime you see sorted, the order is very what? Important. And since the order is very important, we need to compare to know how to arrange it, in which order. So if a class implement the what? The comparable interface, then by default it follows the what? The natural order, which could be alphabetical or increment of 1, 2, 3, or one, whatever that you call it. If you don't use the comparable interface, then you might use the what? The comparator. So all these things applies to either the sorted set or the sorted what? Map. And which class contains that? The concrete class. Any class that starts with a tree implement what? Either a sorted set or what? Sorted map. So anytime you see tree, it means that class might implement what? Comparable interface. Then you will write the compare to method in those classes. So in the comparable interface, you have this method, compare to method. You pass the object that you want to compare to. When you override this one, it will override this method for you. This method returns 0 if the strings are equal. It returns, you can see it returns an integer. So it returns 0 if the strings are equal. It returns less than 0 if the object is less than the specified object. If whatever is coming is less than the specified object, it returns less than 0. Then greater than 0 when the other one is greater than the other one. So it only returns what? 0 if they are what? Equal. Negative is when whatever is coming is less. If it's greater than 0, whatever is coming is greater than what? Whatever already exists there. So before we talk about the natural order, if you wish to provide natural order for your object, you must implement our comparable interface. Then you have the comparator interface. Look at the method difference. So the comparable has what? Compared to method. Compared to. Whilst the comparator has what? Compare. They all behave the same. Comparable, compared to. Comparator, compare. So if the objects are equal, it returns 0. If the first object is less than second object, negative. First object is greater than second object, positive. Then the equals method, before we talk about it, it returns true if the objects are equal. And don't forget, all this comparator interface, either the comparator interface or comparable interface, they only work on what? The sorted what? Collection types, either sorted set or what? Sorted maps. And how do you know the concrete class? Which tree? Anytime you see the tree keyword, it means what? Sorted something. How do you know that? Let's check from here. You can see from here that this is a tree set. This is a tree set, and this tree set is coming from a sorted set. The same with the map. Tree map. It's also coming from what? Sorted what? Map. So if you use either tree set or tree map, then that object that you'll be using this on, that object must implement either what? Comparable or what? Comparator. If you are using comparable, you override the what? Compare to. If you are using comparator, you override the what? Just the compare. So the compare. Compare and the equals method as well. But this one has only one method. Comparable has only one method, the compare to. While this one has two, the compare and the equals. The comparator. It has the equals method and the compare method. So comparators are useful when objects must be sorted in different ways. For example, employees need to be sorted by first name, last name, start date, termination date, and salary. A comparator can be provided for this case in different ways, not in the natural order. So some collection algorithms. Java provides a series of pre-written algorithms based on the collection interface. So you have the max, you have this binary search, that's what I want to talk about. Synchronize, sort, shuffle and reverse, list. All these are algorithms implemented for you by the collection interface. So you can play around with it if you want to perform a binary search on any list. There's a method for that. If you want to copy one list to another, there's a method for that. If you want to fill a list with an object, there's a method for that. If you want to reverse the list, if you want to shuffle the list, there are a lot of methods for you. If you want to sort it, it's also there. Note, collections can only hold what? Objects. They don't work on what? Primitive types. So if you intend to use any of the primitive type data type, you must use what? The wrapper classes. So let's talk about the wrapper classes. So let's move to the code. So here we are going back to our where we left off. Okay, let me just create a new interface. So we just create